In this lesson, we're going to try and solve this problem. So the first job we need to do when we're given a problem like this is read the problem fully, then go back to the start and pull out the important stuff. So let's do that. So a city tower construction uses 4,520 tonnes of cement trucked from a factory that is 7 kilometres from the construction site. Each cement mixer can carry 7 tonnes of cement, and the cement costs $85 per truck for the first 30 loads, and then $55 per load after that. So we have to answer a series of questions here. How many loads of cement are needed? Add a full load for any remainder. Find the total distance, find the total cost, and find the difference in cost with another supplier. So the first thing we need to do is highlight the important information and pull that information out of the problem. So we can see 4,520 tonnes, we'll need that number, we'll need this number there, we'll need this number here, this number here, and this number here. So let's pull these numbers out of the problem. So let's say here, let's write down the information we have. We require 4,520 tonnes of cement. So 4,520 tonnes. The factory is 7 kilometres from the construction site. So let's draw a little picture here. The factory, the construction, and the distance between the two is 7 kilometres. Each cement mixer can carry 7 tonnes of cement. So cement mixer can carry 7 tonnes, and the cement costs $85 per truckload. So that cost $85 for the first 30 loads. And then it also says $55 per load after that. So still a 7-tonne load, but that will cost $55. Full load, 31 and higher. So now that we've got all the information out of the problem, we've summarised the problem, and we understand the problem, let's start answering the questions here. So how many loads of cement are needed? Add a full load for any remainder. So we know that we need 4,520. Each truck can carry 7 tonnes. So we need to see how many truckloads go into 4,520. So we use division for that. So 4, 5, 20 divided by 7. Let's get our calculator out for this one. So 4, 5, 20 divided by 7. So 645.7, and it keeps on going, the decimal places. But it says in the problem A that we add a full load for any remainder. So we need 646 loads. So approximately equals 646 loads. That answers part A. We'll go to part B. Find the total distance travelled by the cement mixers to deliver all loads, assuming they need to return to the factory after each load. So they start at the factory, they go to the site, then they return to the factory. That's one complete load. So for that one, we have 7 kilometres. So 7 kilometres times the number of loads. So one load goes from the factory and delivers the concrete to the site, that's 646 of those. But every time it gets to the site, the truck needs to go back to the factory. So it needs to go back. So we times it by 2. And what does that equal? We'll get our calculator out. Seven times 646 times 2, 9,044 kilometres to deliver all those 646 loads. Okay, number C. Find the total cost of cement needed to make concrete for the tower at the site. So it says we need have 30 loads cost $85. So we know it is well above 30 loads. We need 646 loads. So we're going to have to pay that cost for the first 30. 30 times 85. And I've already calculated this one. This one is $2,550. But we need to calculate the cost for the remaining loads. So $55 for every load after that. So we need to take 30 off the loads we need. So 646 take away 30. And that number that we calculate here, we times that by 55. So I've done this calculation already. It gives us 33,880. So the total cost is equal to 2,550 plus 33,880, and that is equal to $36,430. Okay, part D. A different cement supplier offers a price of $65 per 8-ton truck, no matter how many loads are needed. So find the difference in cost of the cement for these two for the tower by this supplier compared to the original supplier. So the key part is here. We'll just underlined that bit of information. Part D. So we need to work out the cost that this new supplier, the total cost that the new supplier will charge to deliver all the concrete. So it is an 8-ton truck. Remember, the original is a 7-ton truck. So we need to see how many loads it will take this 8-ton truck to deliver 4,520 tons. So we need to divide that. So 4,520 divided by 8. I've done this calculation again. So this is 565 loads. We can see this makes sense because a bigger truck takes less loads than the smaller truck. Now it costs $65 for every single one of these loads, so we need to multiply that. So therefore, go down the page, 565 times $65 a load. And that equals 36,725. And we can see the difference here. So the difference between this and this, we use our subtraction. So difference equals 36,725. Take away 36,430. That equals $295. So this one, supplier 2, is more expensive by $295 compared to the original supplier. So it is better to go with the original supplier. Okay, this completes this problem solving lesson.